Okay, this is going to be a video about how to simplify radicals. So before we get into that, we need to review a couple of things. So for one, in order to simplify radicals, you have to know what perfect squares are. So perfect square is any number that if I take a number and square it, the number I get is a perfect square. Or if I think of that in reverse, if there's a number I can take the square root of and get a whole number answer, then that number was a perfect square. So, for example, 1 would be a perfect square because the square root of 1 is 1. 4 is a perfect square because the square root of 4 is 2. 9 is a perfect square because the square root of 9 is 3. And so if I keep adding on to this list, perfect squares, some perfect squares would be 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, 225. So that's all the way up to 15 squared. Okay, so if I was going to take the square root of one of these numbers, like the square root of 100, my answer would just be 10. It's a whole number answer. If I wanted the square root of 5, that is not a whole number answer. That's not one of my perfect squares, nor does it have any perfect square that I could put into it other than 1. So if I typed that in my calculator, it wouldn't give me a whole number. It would give me a decimal value, 2 point blah, 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 and it would keep going. So sometimes we have numbers like, let's say, the square root of 12. 12 is not a perfect square, but it has a factor that's a perfect square. And whenever we're talking about these factors, we're not talking about 1, because 1 and that number would just be what those factors are. So if I think about the factors of 12, I want to think of a factor that is a perfect square. Okay, so 4 goes into 12, and 4 is a perfect square. So I'm going to take this 12, and I'm going to say that's the same thing as if I said the square root of 4 times the square root of 3, because 4 times 3 would give me 12. So I've just taken the 12 and broken it into two factors. Now, the square root of 4 will give me a whole number since 4 is a perfect square. The square root of 4 is just 2. Now notice when I wrote this 2, I did not put a radical on it, okay? And in case you've forgotten these words, whenever we're talking about what you might say the square root symbol, that is called a radical, okay? So notice when I took the square root of 4, it is just a 2, just whole number 2, not square root of 2. Square root of 3, I can't take anything out of that. That's not a whole number answer, so I'm going to leave that as a 3. So my answer would be, when I simplify that, 2 square roots of 3, or you could say it as 2 times the square root of 3. Okay, let's look at another example, square root of 18. So I want to think of two things that would multiply to be 18, one of those numbers being a perfect square. So if you think about factors of 18, you might think, well, 6 times 3 is 18. And it is, but neither one of those numbers is a perfect square. So those are not the two numbers I want to use. I want to keep thinking. So 9 times 2 is also 18, and 9 is a perfect square. So those are the numbers I'm going to use. And notice that I'm writing my perfect square number first. I like to do it that way just because then I don't have to change the order of the numbers on my next step. So the square root of 9 is going to be 3, and the square root of 2 will stay the square root of 2. So the square root of 18 simplifies to 3 times the square root of 2. All right, so I'm going to go to a new page and pulse. So let's say the square root of 60. So I want to think about all the things that multiply to be 60, and if you can't just think of them in your head, you might want to list them out to the side. Oops, 2 times 30, 1 times 60, 3 times 20, 4 times 15, 6 times, oops, I missed 1, 10, 5 times 12. So those are all the factors of 60. Do you see any numbers in this list that are perfect squares? You see a 4. So I'm going to use the 4 and the 15. So we're going to break this into the square root of 4 times the square root of 15. The square root of 4 is 2, so this simplifies to 2 square roots of 15. All right, another example, square root of 75. So again, either think to yourself or start listing to the side things that would multiply together to give you that number. And so you want to pick the set that has a perfect square listed with it. So this is going to be the square root of 25 times the square root of 3, which is 5 square roots of 3. So that would be simplified. All right, square root of 48. So if I were to list all the factors of 48, you're going to see that this one becomes slightly more complicated because there is more than one perfect square in its list of factors. And so if I list these, you'll see that there's a 4 and there's also a 16 in the list of its factors. So if there's more than one factor that's a perfect square, you want to choose the largest one. And so for that reason, I'm going to use the 3 and 16, not the 4 and 12. So it's important to think about all of your factors and make sure you're choosing the bigger number, especially the larger the numbers are that we're working with. You want to look at all of those. So we're going to make this the square root of 16 times the square root of 3. The square root of 16 is 4, so this is 4 square roots of 3. Now let's say that you didn't realize that 16 was a factor and you chose 4 and 12. Okay, so if I had done that instead, then you might have had a problem that looked like this. This would be 2 square roots of 12, which doesn't look like my answer. But the reason it doesn't is because 12 has a perfect square factor also. I could take that 12 and I could break it into the square root of 4 times the square root of 3. The square root of 4 is 2 times that 2 that was already out in front makes that 4 square roots of 3. So I get the same answer, but you can see when I didn't choose the biggest perfect square, it was a lot more work to get to that answer. Okay, so I'm going to show you just a couple more examples. I have the square root of 300. So this is another one where you'd have several different things that could go in it. 4 is a factor, 25 is a factor, but the biggest one is 100. So I'd use 100 times 3. That would be 10 square roots of 3. And then sometimes you have some like this, the square root of 98. And at first it may seem like there's not a perfect square that goes into it, but there is. It's just one larger than we use many times. So we're going to make this the square root of 49 times the square root of 2. So that is 7 square roots of 2. And then something else I failed to mention, if I had something like the square root of 10, there is no perfect square factor of 10 except for 1. So you can't simplify it anymore. You would just leave it as square root of 10.